Salutations from the stars. I am Professor Copperstein. Last week I promised you a video on capacitance, and here I am. Now, what is a capacitor? Basically, it's a component, an electrical component that, as its name implies, stores charges. Now, the unit of capacitance is what is called a farad. F-A-R-A-D. It's basically how much charges it can hold in every volt. So, take a look at this. The formula for capacitance goes as such. Capacitance equals charge over voltage. Now, every farad of capacitance, as it implies earlier, it's 1 coulomb of charge for every one of its volts. Now, this is a basic one. Now, usually, some capacitors have what is called a dielectric substance. Dielectric substances are non-conductive materials that allow it to charge. In this case, we use kappa, the dielectric constant. Now, the dielectric constant changes. It changes based on the material itself. For air, kappa. For air, kappa equals 1. That's for air. So that's why this usually is just by itself. Sometimes it'll use the dielectric constant that is more than 1, and in this case you need to include the kappa. Capacitors work like a very small battery, except there's a difference. Here is the battery. I have to hold it like this because I don't want to avoid I want to avoid copyright issues. So this is a battery. Just like every other battery, it has a positive and a negative terminal. Some capacitors also have a positive and negative terminal, such as this one. These are polarized. That's the positive end, and this is the negative end. The black stripe tells you that this side is negative. Now, the main difference between a capacitor and a battery is that batteries are designed so that when connected to wires, when you close the gap between the terminals, they release the charge. The positive end loses electrons, and the negative terminal accepts electrons. Son of a bitch. Sorry about that. Capacitors are different. Capacitors are there to store the charge, and so the positive terminal accepts the electrons, and then the electrons go in and they're stored into here. And then, now, inside each capacitor, now this is more or less a schematic of a DC source with a capacitor. Now, capacitors work such that they have 2 metal plates, usually aluminum, with a dielectric substance between. Some use air, and some use like a thin sheet of paper. Now, the source brings out the electrons going this way. Electrons go, and then just as the source does, the electrons go to the negative port. And the electrons stay there, while some continue on and complete the circuit. A natural example of a capacitor working would be lightning. as vetted by howstuffworks.com, this is the ground. I draw it curved. I draw it curved because I want to tell flat earthers that they're stupid. And this is the cloud. The positive end would be the cloud. The negative end would be the ground. And a lightning strikes. Lightning is basically the electrons moving there. The space between is the dielectric constant. The dielectric substance is air. So, in this demonstration, I have here on my circuit board a capacitor here. This one is 100 microfarads. Now, take a look at what happens when I remove the ground wire. Notice how it fades. Now I'm going to remove the capacitor. Now, take a look at the way it turns off. Notice how it's sudden. Okay, I got it back in. Yeah, it's the right way. Yeah, by the way, this is a polarized capacitor, which means if you put this on, you can damage it. In fact, some of them can explode. Now, take a look at how the LED goes off now. Notice how it just fades. Now, if this capacitor had a greater capacitance, then it would have lasted slightly longer. This is because the capacitor does as it's told, it stores the charge. Then as it stores the charge, as soon as we remove the power, the remaining charge goes through and into the LED, and it discharges, basically. In fact, there's a formula for it. So here's how it follows. It's the remaining voltage that it has, which equals the initial voltage times E, the constant E, raised to the power of negative time over RC, resistance capacitance. Now, basically what this is it shows how much voltage is left by the capacitor after a certain amount of time lapses. Other important things you need to know about capacitors is that, first of all, there are different types. This is a polarized dielectric capacitor. It's polarized. As we said earlier, if you put it the wrong way, it can possibly explode. Now, this here is a ceramic capacitor. It's tiny and kind of cute. I think they're cute. and sometimes it can function as a small battery, and these are non-polarized. So you can put them in whatever way you want. So like this, like that. Now, how to calculate the capacitance when you see a capacitor? Well, easy says now these on the dielectric ones, these types, they'll say it right there. This one here is a 100 microfarad. Now, on the case of this one, now it's very, very faint, so you might not see it. look for it. Okay, these are small, so like the resistors, they also have their own code. For this one, it uses 3 numbers. The first 2 numbers are a simple 2-digit number, but this 2-digit number is the capacitance in microfarads. And the third number is a multiplier, times 10 to whatever number is specified. Now, since you're not able to see it here, it's very, very faint. The number is 101. That means 10 microfarads times 10 to the 100 to the first power. So basically 100 picofarads. Is it picofarad there? Okay, let me just repeat myself. The first 2 digits of the number is the capacitance in picofarads. If I said something else, then disregard that. If you're taking notes, then erase that and say that the first 2 digits are the amount of capacitance in picofarads. They're now unclear. And the third number is the multiplier. So 101, well, 101, that's 10 picofarads times 10 to the first power. In this case, 100 picofarads. So this is a very small. Now, capacitors like these, this one's a small one, so it's relatively safe. But there are some like this that can be big, like a soda can. Those can have capacitances way higher, so high that the remaining charge inside can be dangerous, if not lethal. So sometimes when you take apart a machine, like say a washing machine, and you notice there's a capacitor in there, you notice they have like ones like this big. Those can probably be dangerous. It depends. I mean, some are not that bad, but the really big ones, those are dangerous. Okay, you can burn yourself, you can electrocute yourself, and so it's best to like decharge them. To discharge them, either leave them alone, or even what you can do is put like a wire between them and then, like, you know, connect them. Kind of discharges them. That's what I heard. So that is my video on capacitance. I hope you enjoyed, and if I got anything wrong, feel free to tell me. I'm not gonna get mad, and I love to learn too. So thank you for watching. Be sure to like and subscribe, and check out my other videos. Leave a comment, tell me what you think. Also, do follow me on Twitter if you'd like to hear more about me. So, and remember, regardless of how late you are, there is always time for science. Transmission out.